Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. This episode is part 2 of Linux security best practices. And once again, we've asked Don Pizzette to help us out because he's a heck of a guy. Don, good to see you.
Hey, glad to be back. And this is part 2. In the first episode, we got a chance to learn about a lot of security best practices in the Linux world. And in this part 2, what I want to do is take a service in this case that should already be secure, the SSH or Secure Shell service, daemon, and I want to show how we can harden it to actually make it even more secure. And this is a process we'd repeat with any number of services that we run on top of a Linux box. So it'll be a great example to see what we can do to implement some of the security best practices. So we'll take a look at how SSH is configured and installed. We'll see some of the options we can change and secure it. And then we'll see some of the things that we can do as an end user when we're connecting using SSH, all to ensure the most secure communications possible.
So Don, how do we enable SSH?
All right, this is actually part of the reason why I picked SSH, and that's because pretty much every distro today not only has SSH installed by default, but they have it enabled as well. So when it comes to how do I install SSH, odds are it's already there, right? If not, you can install it pretty quickly. If you take a look, like I'm on a CentOS box, and CentOS, Red Hat, Ubuntu, Debian, Fedora, they all have SSH installed and activated by default. So you can pull up your package manager and look, like I can do a sudo yum list, and I'll just look for SSH star, right? And you might find a package in there that's called SSH or SSHD. If you don't find it, like I didn't, I found a package called SSH pass, then it might actually be called Open SSH, because this comes from the Open SSH package, which is actually maintained by the OpenBSD people. So if I go and look for that, there it is, right there. And it's under my installed packages. So it's already installed. If it isn't, you can install it. The package is normally going to be called either SSHD or OpenSSH. Once you install that, that gives you that functionality. And notice how there's OpenSSH clients and there's the OpenSSH server. And all three are installed here on mine. And not only are they installed, we go a step further, they're actively running. My system is ready to act as that SSH server. Now, we can trust the default configuration from the vendor and just run with that. But a lot of times you'd be surprised to find out that they've set security levels to be at a low enough level to ensure the most compatibility and blocking like the most grievous of attacks. But there's really common attacks that may still function even on the default install. So we've got to go and revisit that.
So how do we start hardening the SSH service?
All right, so we start on the server side. Now, SSH has two pieces, server and client.
Right.
And mistakes can be made on either side. So we could spend a ton of time making the most secure server as possible, and the client can still screw it up and blow security out the window, right? And the reverse is true. A client can be taking all the steps possible to use every precaution and ensure a secure communication. And if the server is misconfigured, things get botched there too. So we have to look at both sides of the communication. And this goes for anything. Email server, same thing. Web server, same thing. It is always possible you've got two parties involved, something can go wrong. So let's start with the daemon, the server side, okay? I mentioned it's already installed, and I mentioned it's already running. And we can verify that with systemctl status, SSHD. And so when I run that, I can see right here it's active, it's running, and I can see where it's systemd target or unit is being called from. So it's there, and it's actually up and listening on port 22. Now, on my system, it's listening on port 22. There are some distros that are more secure that will default to a different port number. And they'll say, look, everybody knows SSH runs on port 22, so we're going to pick a different port number and run it from there. All right? That's fine and good, but that's really just security theater. That's not actually securing it. If you switch to a different port number, that's going to slow an attacker down by half a second, right? When they find an open port, they then go and analyze it to see what that port is. Doesn't really matter what that number happens to be. So that's called obfuscation, where you're not actually securing something, you're just hiding it and hoping people won't find it. Well, people typically will. So you can change the port number if you want, but most distros just leave it at that default of port 22. Now, all of that is coming from SSH's configuration. And we can find that inside of /etc/SSH. If you look inside of that folder, you're going to find a number of files. And be careful in here because the names are really, really similar. For example, if you look at these two files over here on the left, there's SSH_config and SSHD_config. Okay, the first one, SSH, that's the client. So if I'm using the SSH client, those are the settings that'll apply. And then SSHD, that's the daemon, that's the server side. If I didn't install the client, I might not have that first one, and I would just have the second. If I didn't install the server, then I might have the first one and not the second. In my case, they're both installed by default. In your case, they usually will be too, so you'll see both files. So for the server side, we want to mess with that SSHD_config. And so let's take a look at that real quick. I'm going to edit that file. And actually, a lot of what I'm going to do this episode is going to require administrative privileges. So I've got to make sure I use sudo when I work with these files. So I'm going to do sudo vim /etc/ssh/sshd_config. Now it's just a text file, and inside of there, I'm going to find the configuration. And as I look down the list, I'm going to see a number of things in here, including right here at the beginning, something that's commented out, right? Where it's assigning the port number. If I want to change the port number for SSH, I would uncomment that line, just remove the pound symbol. And so if I were to get in there to do that, I would remove the pound symbol and then just change that to a different number. So maybe I want this to be on port 1386, like that, or 1000 or 13,386. Let's go really high, right? You can pick a number, pop it in there, and when you restart SSH, it'll run on the new port number. Now, be careful if you're running AppArmor or SE Linux, they will have policies that allow SSHD to run on port 22, not on this custom port. So you would need to go and add it to SE Linux, add it to AppArmor. If you have your firewall, it's going to have to allow this port to come in, right? But as far as SSH is concerned, if we just change it right here, restart SSHD, then it's going to read that. You can also bind it to particular IP addresses. Right now, it's answering on any interface I have. Well, if I'm using my Linux box as a firewall, and it's got a public interface and a private interface, I probably don't want to answer on the public interface. I don't want the world to be able to SSH into that firewall. I would want it on the inside interface. And so I could restrict it right here and tighten that up, right? Now, I'm not going to change that default port number, so I'm just going to comment that back out again. And as a rule of thumb for me, what I usually recommend is if you're going to change a default value like this, I recommend that you leave the line the way that it was and add another line that actually has the new value that you're specifying like that, okay? By doing that in the future, it's easy for you to come and see, oh yeah, the default was port 22. Maybe I want to put it back. And if you want to put it back, you can just comment out your new line and then uncomment the old one, right? So it's easy to switch back and forth from the defaults. And if they're all commented out, then that forces it to go to the default also. But most of the services are documented just like this, where they show you what the default was, even though the line is commented out. So that's a pretty handy thing to have. All right. So that's the port number. That's one thing we might want to adjust. As you keep scrolling down, you'll see a number of other things, and I'm looking for one specifically. I'm looking for the protocol version. So SSH has been around a while, and there was SSH version 1, the original version, and now there's SSH version 2. SSH version 2 uses much stronger encryption and is considered significantly secure. It can use a larger key. SSH version 1 is no longer considered secure, right? The keys aren't that big, and computers have come along quite a ways over the decades, and it is possible to break an SSH 1 session. There have been several proof of concepts of this. So SSH version 1 is frowned upon. Now, technically, the client gets to pick the version. So on the client, when they connect, they can say, yeah, I want a version 2 session, or I want a version 1 session. Well, my system is likely set to support both. So somewhere in here, and I'm having a hard time finding it, so I'm going to do a search instead. So somewhere in here will dictate that version. And what I normally do is I take away that decision from the client. I'm going to do a / here to search for protocol. And, oh, there is no line entry in here. Okay. So if there's no line entry, then it's defaulting. I have no idea which version it's using. Is it using version 1 or version 2, and what order it's using? I don't get to see that. So I'm going to add a line in here to force it, right? So this is one that's just not in the default config. So I'm going to add a line that just says protocol 2, like that, okay? By specifying protocol 2, I'm telling it to run in version 2 mode. If somebody tries to connect using SSH version 1, I'll reject the session, right? The default is to let the client negotiate, and the client can ask for version 1. And now, even though I've got a server that supports version 2, the client has ruined it, right? And now we end up with this weak connection. So that's another example of something we might do to strengthen the security of it. Now, because that option wasn't listed here in the documentation, I may want to double check, and it may be that the folks at CentOS made that decision to say, you know what, we're just going to strip out version 1 support altogether, right? Not every distro does that, so look for that protocol option, and you can always manually enter it in if you want, all right? So that's a couple of things that we can tweak right here in this file. Those changes don't take effect until you restart SSH, right? So to restart this, I'm going to do a sudo systemctl restart sshd, and that's going to give it a restart. So it'll shut down and come back up. It'll read that config file, and now version 1 has been disabled. And if I had changed the port, that would change. I ended up leaving it at the default, right? There are some other things that I'll want to change. Looking at this directory, we saw the config files, but there's also all of these key files, okay? You'll see, a file that ends in just key, not an extension. It's just it's got key at the end. And then there'll be one that ends in .pub, okay? What this is a private key, the one with no extension, and then a public key that ends in .pub that's calculated off of the private key, all right? When this system was installed, it created 3 sets of keys. I've got an RSA key, an ED25519 key, and a ECDSA key, right? 3 different keys, 3 different strengths, right? 3 different encryption algorithms. So, different uses for each one. And again, the client gets to kind of pick which one they want to use. Now, I didn't make these keys. The system made them for me. So can I trust those keys? Well, it depends. A lot of distros, when you do the install, the system reboots and they generate the keys when they boot, right? And that's pretty ideal because if you install on 500 machines, in theory, you'll have 500 different keys that are all generated the first time they boot, all right? But there's a few problems here. One problem is sometimes they generate those keys prior to the random number generator having enough entropy in the system. So in Linux, you have a random number generator, right? You actually have 2, but if you take a look at /dev, inside of /dev, you'll find a device in there called /dev/random. That guy right there. And that relies on hardware entropy to generate a random number. That's what we want to use. But if this is your very first time booting, it may not be populated with a lot of entropy, especially if it's a virtual machine. And so in that case, it ends up using /dev/urandom, this guy right here. That one doesn't use hardware. That one uses software to try and come up with as random a number as possible. Well, I think everybody is kind of in agreement on this, that computers don't do a great job of generating random numbers. So there's the potential that there's some predictable sequences that can occur. And there was actually a known exploit for this 2 years ago where there were certain distros where you could predict at least a handful of bits of what it was going to generate the first time that it booted after an install. And that meant those keys weren't reliable. Worse, there's a couple of distros out there that have already generated the keys and they're on the installation media. So when you install, if you install on 500 machines, all 500 have the same private key, which is terrible. So the moral of the story is you shouldn't trust those keys if you can avoid it. And if we wipe those out, we can generate our own. So that's kind of another thing that I'll go in and kind of put in place to help secure SSH.
So Don, how do we generate new keys?
It's really not that hard. First off, you want to get in and delete the existing keys. And then we've got the utilities built in to be able to build new keys. That's what OpenSSH does, is how these keys were hopefully generated.
Right.
So if we want to build some new ones, let me walk you through that process. So I've got this new system, right? So I installed CentOS, just did the default install. We've been messing with it in other episodes, but these keys are what were generated during the install. So I'm going to start by removing those. All right. So I'm just going to do an RM, and I'm going to get anything that has _key in the file name, right? So we're just going to blow those 6 files away. And also, I've got 6 files. I've got 3 different keys. Depending on your distro, you may have more. There may be other protocols or encryption algorithms that are supported by your distro, so don't be surprised if you see some other ones. But I'm going to blow those away. And shoot, I should have done a -y, so I didn't have the prompt on each one. Oh, and I forgot to sudo it. So let me do an RM. I'll just do a -f so I don't get prompted on everyone. And now when I take a look, I still have my SSH configuration, but SSH is now broken. right? It's broken because there's no keys. If somebody tries to connect right now, it's going to fail. So I'm going to go a step further and just do a systemctl stop SSHD. So I'm going to shut down SSH on my system since nobody can connect right now anyway.
Right.
And then I'm going to generate some new keys. All right. So to do that, I need to sudo this because I need to put the keys inside of /etc/ssh. So you've got to be an administrative user to do that. So I'll do sudo, and then I'm going to call a utility, which is ssh-keygen, right? So that's the key generator for SSH. And we're going to be generating a private key and a public key based off of that private key. And the way we do that is by telling it what type of key we want to generate. Remember, I had 3 different keys. If you had 2 keys or 5 keys, you just need to pay attention to the type. And the type is what was listed in the file name. So I had RSA, ED25519, and ECDSA, right? Those are my 3. So those are the 3 that I want to rebuild. So I had to do them one by one. So I'll start with that RSA, right? So -T RSA. And then I just tell it where I want to put this stuff. So I'll do -F, and I'm going to point to /etc/ssh/SSH_host_RSA_key. I'm not making that name up. I'm using the exact same name that it had before because I'm just replacing that key. The SSH configuration or the SSHD configuration expects those files to have that name. So I don't want to mess with it. If I change the name here, I've got to go and change it in the configuration file. So this saves some time. All right. So when I run that, it's going to go and generate the key pair. It's going to prompt for a passphrase. You can stick a passphrase on there, and if somebody wants to view the private key, then they would have to provide it. That's a bit of a problem for the SSH daemon because it's going to fire up and it doesn't have the passphrase, right? So I'm going to leave that blank so that it'll be able to access it, and then it generates that key. Now, it's going to show me the key fingerprint. So I see that right here. When you remotely connect to an SSH server as a client, it will show you the fingerprint and say, is this the host you meant to connect to? This is the way that we verify, okay? But I'll tell you right now, I am super #1 guilty of not documenting this key. So I'll show you another way to get it here in a few minutes. But now I'm going to follow that up by generating the other 2 keys. That was the RSA. Then I'm going to do the ECDSA. Or wait, we had ed, was it 25519? Was the other one ed 25519? Yeah. 25519, which always makes me think of RoboCop, you know, the robot in that one.
Yeah, I have one of those.
What was that? It was like Ed 209
Ed 209 or 109 or
I'm sure these
something.
are built on the same technology.
Yeah.
So I'm going to go ahead and generate that one, and I'll do the same thing, no passphrase. And then the last one was ECDSA, which is actually the one that's used by most SSH clients these days. So that's the most important one for me, ECDSA. There we go. So it's going to generate that one. Okay. So each one has been generated, and if I take a look at my folder now, I see all those files. Now, technically, I'm right back where I was a few moments ago, except I know these are brand new keys that I generated myself that were generated after the system had plenty of time to generate tons and tons of entropy. So these are going to be good keys that I can count on. And so now I can just do a sudo systemctl, and I can start SSHD again. And now I'm back up and running, and I'm running with my own keys.
What's the best way to distribute the public key to users?
All right, so if users are going to connect, they need to know that public key, right? Well, technically, SSH hands out the public key to anybody who connects, right? So if I were to SSH into this server right now, so I'm going to do SSH dposit at 127.0.0.1, right? So I'm SSHing into my server. The first time I connect, I get this screen right here, okay? And what it's saying is, look, we're connecting to a host, but we don't know if you can trust it. All right, so here's 2 fingerprints. And so it's showing me the ECDSA fingerprint. Remember, I said that's the one that most clients use today. So that's the one I picked. Mine didn't do the ED 25519 or the RSA. Now we're all going to think of RoboCop. So it picked the ECDSA one, and it's showing me 2 different fingerprints. And it's actually the same fingerprint, but run through a different hashing algorithm. The first one is using SHA-256. The second one is using MD5. And then it's displaying the fingerprint and saying, is this the right server, right? Well, if I had documented it, I would simply look at my paperwork, right? I'm going to go all the way back up here. Where did I generate the ECDSA? And when we find it in here, I can find that fingerprint. Actually, I guess that was the last one I did here. And see how it starts with WQU and it ends in DI0. And so if I look down here, I can see it starts with WQU and it ends in DI0. It is the same fingerprint. And so I know that I've connected to the actual server that I intended to connect to, right? But if you're just a regular old end user, how do you really know that's the right server? You get some crazy fingerprint on your screen and you don't know. So we don't actually need to distribute the public key. When a client connects, they're going to get the public key during the connection time. What we need to distribute is that fingerprint.
Right.
We need to let people know, hey, this is the fingerprint you should be expecting. Now, Zach, if I were to send you an email with this fingerprint in it, you're not going to remember that, right?
I don't think so.
So every time you connect to the server, you'd have to fire up your email, you'd have to find that link or whatever. It's a super pain.
Right.
So in Linux, what we can do is we can store that fingerprint on our client. And when we store it there, we'll know we're connected to the trustworthy server automatically, right? Right now, when I SSH that server, the fingerprint's not recognized. I get this prompt, okay? But if I know the fingerprint ahead of time, I can take that and I can add it to a file. In your home directory, and every Linux user has a home directory, if you've ever used the SSH client even one single time, then you should have a subfolder in your home directory that's hidden, and it's called .ssh, right? So if I do an ls-a, I should be able to find a .ssh folder. There it is right there, okay? And if you go into .ssh, it might be empty. Mine is apparently empty. Or you might find a file in there, a file called known_hosts, right? And it's a text file that contains the public key of each host that you trust. And so what I could do is I could say, all right, if I know Zach's going to be SSHing to this server, I could take the public key and give it to Zach, and he could put it right into that file. Or even better, I could put it in the file for him as part of like the skeleton profile. When I create a user account, I can have that copy over and pre-populate it with public keys. Remember, a public key can encrypt data, but not decrypt data. So I can give it to whoever I want. It's no big deal. They're not gonna be able to decrypt anything with it. And as long as they've got it in their known hosts file, they'll trust the server, okay? Now, I just set this server up so I can actually have it add that for me. So I can use another utility called SSH-keyscan. Okay, now I don't need to sudo this one. As an end user, I can say SSH-keyscan, and I can point it to a server. And it can reach out to that server and grab that public key and put that into my host file if I want to. And that way it's already in there and I've got it. So I'm going to do SSH-keyscan, and I'm going to point that at 127.0.0.1 because I'm on the server that I'm wanting to scan. You could do the public IP or the host name for that server, you know, whatever it is. And if I just run it like that, right, it's going to look at the server and it's going to display the public key right there on the screen, right? So if you're like me, you know, and you didn't document it when you created it, here's a quick way that you can get that public key. I can also take that though, and I can pipe the output. I'm going to use double greater than signs. And what that says is I want to add the output of this command to a file. I don't want to overwrite the file because then I would lose any existing keys. I want to add to the end of it. So I'm going to add to a file, and I'm going to point it to // so my home directory, .ssh/known_hosts, right? That file. The file likely already exists. If it doesn't, this will create it, right? So it runs the command, and then it puts those public keys right in there. And I'm seeing the public key for RSA, for ECDSA, and for ed25519. All three keys have been added to my known host file. So if I take a look at that, I'm going to just cat the /.ssh/known hosts, and now I can see those entries right there. And you can have 100, 1,000 different servers. All the servers that you connect to can all be listed in here. And now that it's there, remember when I SSH'd a moment ago, it said, hey, here's this fingerprint. I don't know if we trust it. Are you okay with it? Right? This time, if I try, so I'm going to SSH as dpossett into my server, right? This time, it didn't ask me. It says, oh, that's a known host. Yeah, I've got the fingerprint here. It matches what the server gave me. I'm connected to the right server. And now it's just asking for a password, and I can punch that in, and now I'm connected into the system, and I'm working, okay? So by doing that, we trust the server, right? Now, a lot of people get lazy, and they say, all right, I'm going to SSH into some host, and I'll just trust whatever key it gives me, right? So if I were to SSH as dpossett at, and, you know, I'll point to some other system on the network, right? And so here I get this prompt. Do I trust that box? Yeah, sure, I'll just say yes. Right? And so when I do that, it's going to go and add that to my known hosts. See how it says I just added the ED25519 to the list of known hosts. Okay. So if I were to take a look at my known host file now, that's in there. Okay. And I can see it right here, this last line. Okay. Now, the reality is, I don't actually know if that was the real system. I might have connected to an attacker's system that's masquerading as mine. I just trusted whatever cert it gave me. So this could be some self-signed, generated thing, compromised, where they know the private key and they're able to decrypt everything that I send. That's the risk. That's why we want to make sure we distribute this key out so that people have it available. And you can actually configure the server. There's an option in SSHD, or inside of the SSH config, sorry, on the client side, where we require the client to have that key in known host to not allow us to learn something that's out there. So for example, if I were to, I'll just remove that known host file and get rid of it. Well, inside of /etc/SSH/SSH config, so not SSHD, this is the client one. If I take a look in there, there is an option in here for, it's called strict host key checking. So somewhere in here, let me just look for the word strict. There it is, strict host key checking. And right now it's set to ask. So I could change that. And if I just remove the ask from it, and so it just says strict host key checking, then it will require me to already have that key. It won't let me just learn it. And we can use SSH Keyscan to be able to find that.
So Don, now that we have the key, how do we use it?
All right. So technically we're already using it, right? We've got the key, but it's just us. We're the only ones that have it. So if we want the other users on our system to be able to use this key as well, right? To be able to like authenticate and trust that public key, then, or trust the server you're connecting to, then we need to make sure it gets distributed amongst everybody, right? And there's a few different ways to do that. I mentioned the /etc/skel folder, right? That folder contains a template. Anytime you add a new Linux user, that gets copied to become their home directory. So I can take the known host file that we just built, the one that is working for our user, and I can copy that into /skel. So if you look, that's probably not there by default. So let me get into /etc/skel, and I'll do an ls-la. And yeah, I can see there's a .bashrc, a .vimrc. So these default configurations for Vim and Bash, but not SSH. I can make a directory here. I'll need to sudo this and just call it .ssh. And then inside of .ssh, I can place that known host file. And now anybody that I trust will be right here. Anytime I create a new user, this will be copied to their home directory and they'll trust it as well. Now, that doesn't help existing users. I would need to take this and copy it into the existing users folders as well. Be careful with that, because if they've already modified their known hosts, you don't want to go and overwrite it. So you always want to make sure you append. And that's what I was doing earlier with the double greater than symbols, was appending, adding to the end of the file. There's a few other things we can do to help our other users too. For example, if I go back into /etc and into SSH, so I'm in /etc/SSH, and we edit that config file for the client, right? So that was SSH_config. And whoops, I need to actually invoke an editor here. There we go. So what we're looking at here is the client-side configuration for our clients, right? And when we're pushing out the keys inside of the known host file, we're saying, look, we already know these hosts, so we trust that key and we're ready to go. But an end user can break this system pretty easy. When they connect to a server they don't know, the server just says, here's the fingerprint. Do you trust it? Yes or no? And if you say yes, it's going to add it to their known host. I might want to prevent that. And if you look inside of the client configuration, you can find this entry right here that says strict host key checking. And see how the default value is set to ask? That's where the client is asking, should we just learn this key? Is it okay? Right? Well, you know how users are. They don't even read the error messages. They just hit yes and off they go. So if we uncomment this line and remove the word ask, then it's going to enforce strict host key checking. And that means that key will need to exist inside of their known host file, or it won't allow them to connect, right? And a lot of times that's what you want if you want to enforce security. But remember, this is on the client side. The clients can really mess up a lot of things. So there are a few other little things that we can do to kind of help the clients out. And let me just show you an example. Oops, dropped into macro mode. Let me get out of that file. Let's say that I just spun up a new server and I did what I'm guilty of and didn't document what the fingerprint was. And the clients, end users, are calling me and they're saying, look, it's showing me a fingerprint. Can I trust it? Well, in your known host file, you don't have the fingerprint. You actually have the key. And looking at that key doesn't necessarily tell you what the fingerprint was. So as an administrator, I can regenerate the fingerprint. The fingerprint doesn't change the certificate. The certificate's always the same. And then we generate a key based off of it. And in theory, the key should always be the same too. Or sorry, not the key, the fingerprint should always be the same too. It's just in my case, I don't remember what it was, right? So we can use the SSH-key scan command, not just to view the certificate of a server or the key, but we can also use it to view the fingerprint, right? When I pointed SSH key scan at my own system, right, it looks at the system and it gives me the 3 different public keys, right? So I see 3 different public keys, and it's actually showing me the signature for that key, not the fingerprint. So this is different from the fingerprint. If I want to see the fingerprint, I can point at the actual key files and regenerate that fingerprint to see what it was. So SSH keygen will do, or key scan will do that as well. So I'm going to do SSH-key scan, and then I'm going to say -LF. So I'm going to be generating a fingerprint, and I'm pointing it to a file. And the file, I'll just have to point to each one. I'll do /etc/SSH/SSH_host_ECDSA_key.pub. Remember, it's the public key that's being distributed out to the end user. So I don't need the fingerprint of the private key. I need the fingerprint of the public key. When you run that command, assuming you type it right, which I didn't. Oh, you know what? I said keygen first, and then I changed key scan. I was right in the first place. So it is keygen. So let me do SSH-keygen. There we go. And it's going to look at that key, and then it's going to spit out what that fingerprint is. Now, notice the fingerprint here is a SHA-256 fingerprint. When a client connects, they're trying to generate a fingerprint too, right? Except they might not be using SHA-256. They might be using SHA-512 or even MD5. And if I give them this fingerprint, that doesn't necessarily help them, right? They can't match it up. So there's another command line argument we can add on here. So I did -LF. You can also add, I'll just go here to the end, and add -E, and it will let you specify what hashing algorithm you want to use. So it's doing SHA-256 by default. If I add SHA-512 like that and run it, whoops, it must be a capital E. Let me change that. There we go. Capital E. Capitalization matters. So there we go. And now it's generated the SHA-512 key for that. So it's a good idea if you're going to be sharing this with people, like maybe you're creating documentation and saying, here's what the fingerprint is. It's a good idea to generate 3 fingerprints. So what I normally do is I generate the MD5, the SHA-512, and the SHA-256. Those are the 3 that are out there. SHA-1 might be in use also. Really, MD5 and SHA-1 should not be used anywhere anymore. They've been proven weak, especially MD5. SHA-256 and SHA-512 is what we should be using. I mean, you can sit here and generate all of them if you want. But now I've got the 3 fingerprints right here. I can share these with my users, and now they'll be able to match that up, even if it's not in the known host file. Now they're not guessing anymore. So that's really better than distributing out the private key, because the private key gets stored on their machine. If they go to another machine, they don't have that key, right? Or, shoot, I said private key. The private key stays on the server and it never leaves the server. It's the public key.
That's right.
So if I distribute the public key to a client and they move to another computer, they don't have the key, right? So as they move around that public key, they need to take a copy with them. That doesn't always happen. But if I can put the fingerprint like this in documentation, now they've got something they can look at and they can see that it matches. Because on the client side, they can break a lot of this. Even things like the protocol version, right? If they use that SSH client, they can come in and specify things like, if I just connect here to my system is going to try and do a SSH version 2 connection, right? Because that's what's secure, what's available. But a client could actually do, like if you just add -1 to the command line, it's going to try and connect using SSH version 1. Like a client can choose to use weaker security if they want. Now mine just got rejected because my server is only accepting version 2 connections. So these are all things that we do to increase security. The key takeaway here is that there's stuff to do on the server and stuff to do on the client in order to harden this and make sure we have a good, reliable, secure connection.
Linux security best practices part 2. I have enjoyed this episode, Don. You did a wonderful job as usual. Thank you so very much. And before we move on, you have something else you'd like to say.
Yeah, I really just bounced around between a couple of commands, and it's easy to mix them up, right? So you saw where I had SSH key scan and SSH key gen. They're both really well documented. It is easy to mix them up. But be aware that just the big thing I cautioned about earlier, anytime you mess with a known host file, make sure you're appending to the end of it, because if you overwrite it, you can lose a lot of keys. Granted, they're just public keys, so it's not the end of the world. You can get them back again, but it's kind of a pain. And for me, I actually have a known host file that I tote around with me. I store it in Dropbox so that I can get it. They're just public keys. So if an attacker gets a hold of my list of public keys, that's zero risk. There's no big deal. All right, so they trust my servers now too. I trust them, so it's fine, right? So it's a pretty low risk thing to carry around, and it helps to ensure that you're actually connecting to the real server and not somebody that's hijacked an IP.
Great advice. And here's some more good advice. Watch every single episode of CompTIA Linux Plus. You're going to be so glad you did. It's going to help you now and in the future. And you need to keep studying, keep going from there. Take advantage of the supplementary information we have on our course library. It is there to do one thing, help you be even more successful. So check that out as well. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again next time.
Thank you for watching IT Pro TV.